All right, another interesting one. You can just give it a try and you can resume to look at the solution. All right, a pretty interesting one. This is basically called as a magic square, guys. And let's see what we have here. The numbers 1 to 9 are arranged in a 3 by 3 square grid in such a way that each number occurs once, and the entries along each column, each row, and each of the two diagonals add up to the same value. So for this particular magic square, as I've told you, in this particular case, you add this particular column, this particular column, or this particular column, or this row, or this row, or this diagonal, or this diagonal, the sum will always be equal. Now let's observe, guys. Let's observe. We know that there would be three numbers in this particular row. Let the sum of these values be equal to x. Similarly, in the second row, there'll be three numbers. Their sum is also going to be x. And in the last row, again, we have three numbers. Their sum will also be equal to x. Now, if you add all these numbers, you're going to get x plus x plus x, and that is 3x. But this 3x is nothing but all the numbers in this particular grid, right? The first row, the second row, and the third row together will be the addition of all the numbers in the grid. In some order, we know that this is going to be the sum of the first 9 natural numbers, right? So 3x is 9 into 9 plus 1 divided by 2. So 2 5s are and 2 10s are. 45 upon 3x is nothing but 15. That means sum of all the numbers across the row, column, and the diagonal should basically be equal to 15. This is a very important breakthrough, guys. And this you can remember for any 3 by 3 magic square. The sum of any row or any column or any diagonal should always be equal to 15. Now that makes things very simple for us. So in the first row, if the sum of all the three numbers should be 15, we already have 6 and 2, 8. We need a 7 in here to get the sum equal to 15, right? So the number in the top center box is the number 7. But if you look at the second column also, guys, the sum of all the three numbers should be 15. So if I call these numbers as y and z, 7 plus y plus z should also be 15. Thereby, I get y plus z is equal to 8. Now, guys, let's observe something. If y plus z is equal to 8, let's look at the different possibilities that we can have. We can write it as 1 plus 7 equals to 8. We can also write it as 2 plus 6 being equal to 8. And then we can try with 3 and 5. Okay. Mathematically, 4 plus 4 is also possible. But we can't write 4 and 4 here, right? Because we have 9 distinct or different natural numbers being used to fill this entire grid, right? So we can't have 4 and 4 in these two places. So I'm left with only three possibilities, 1, 7, 2, 6, and 3, 5. So if I put these numbers, these two numbers as 1 and 7, we already have a 7 here in the first row. So we cannot use 1 and 7 combination. Can we use 2 plus 6 combination? Absolutely not, because we already have 2 and 6 being used in the first row. So I'm left with only one possibility, 3 and 5. So y and z should be 3 and 5 in some order. So now, if the first possibility I take is y is 3 and z is 5, then I want you all to focus on this diagonal, this one diagonal here. The sum of all the numbers in this diagonal should be 15. So if I have 6 here, 6 plus 3 is 9. In this corner cell, I would require a 6 to make the sum 15. But once again, the number 6 will be repeated. That's not possible. Hence, it is the other way around, meaning actually y is 5 and z is 3. And that's pretty much what we want to find out. The bottom middle entry is the number 3. Superb question. Slightly tricky, but I think it's very like logical and something that you can get if you understand the logic of some of the first and natural numbers and apply it thereby.